So, hi. Did you all have a good lunch? Like the food? Yeah. So, I guess we have to thank KubeCon for that. So, this session is about we're running, we're working with a bank, an Indian bank, sort of running Kubernetes in production. We thought there were enough sort of interesting learnings from it that might make for a good talk. Thankfully, the organizers thought so too. So here we are. So I say we. So this session was supposed to be, it was supposed to be a two-person thing with Shekhar Gulati. I think some people may know him. He's kind of known in the community. Unfortunately, he couldn't make it. This is a personal emergency. So yeah, it'll just be me, so he was doing the presentation. PowerPoint is not my primary skill. And then he had to bow out early in the morning. So this is just what I cobbled together last week. So I did a version of this in Bangalore over the weekend just to kind of get some feedback. And then I thought we'd end up with a supremely, superior version, courtesy Shekhar Gulati. But yeah, unfortunately he couldn't make it. He really wanted to be here. I think he worked on it all of yesterday, but there we go. So this is the not as improved version, let's put it that way. So I guess who are we? So Shekhar is the CTO at Xebia in Gurgaon. How many people from out of town? A few of you. Are you from Bangalore, Mumbai? Yeah, because it took me about the same amount of time to come here, right? From Gurgaon. So like I said, Shekhar is the CTO. I kind of do some CNCF related, I drive CNCF sort of activities within Xebia, trying to get more traction. So what is Xebia? I guess we do consulting and IT services. I promise you this is not a sales pitch. I kind of want to set some context. Why am I here? So Xebia does consulting and IT services. We are not in infra because we are not TCS. We do niche stuff. Some of you have been to Xebia, obviously. We have a fairly good DevOps and cloud practice, lots of great cloud experience, not as great at on-premise infrastructure experience. That's not our sort of core skill. We mostly have application developers. We're great at software architecture. Digital transformation is sort of our bread and butter. But we have customers. We do these things for customers. Am I too loud or something? Or is this better? Just okay, great. So digital transformation, like I said, whatever that means. We can do architecture, but we kind of depend on our customers' IT teams to do the, sort of the rest for us. And the reason I bring this up is how many people here are running self-managed Kubernetes, maybe on-prem with their own infrastructure team. So I am probably envious of you guys, if everything is going smoothly. Is it going smoothly? Because you probably have great sort of infrastructure platform teams, whatever. How many people do you have in your IT platform teams? 5, 10, 20? All right, okay. We don't really, infra is not a core skill. We don't want to compete with TCS, right? So now what happens if, so the point is we are not a product organization. We are not a startup. That kind of indicates we get a certain level of application developers. Linux kernel contributors are not going to come work at Xebia as much as we might want to have them. We don't compete with Paytm. I don't think we can compete with Big Basket. In India, and then you have all of your. So internationally, if you're on cloud, there are all these organizations running OpenShift on-prem. There are a lot of people on GCP, on AKS now. AKS is really picking up, and on EKS, on AWS. But we don't have a lot of on-prem skill. We don't have our own data centers either, right? Which means if we set up a platform, a Kubernetes-based platform, essentially I have to get application developers, people I really have, people I trust, and then upskill them. We have to kind of learn that, right? I think we tried to get a really nice, smart infra engineer, and he ended up joining Amazon. So yeah, that tells you a lot about that. So why all of this? So the reason is about a couple of years back, like I said, we sort of tied up with one of our customers, a sort of leading Indian bank. they wanted to sort of go through a transformation exercise, and they came to us for sort of, some inputs. How do they build sort of an API platform, which is very data-driven? There's a data lake, lots of data, data which cannot go on the cloud. It has to, it's bank. RBI doesn't allow you to take stuff to the cloud. So that data has to stay within the bank's data centers. But they want, APIs, they want microservices, and they have to be polyglot because, we are not the only vendor. They have .NET, they may have Python, whatever. So we sort of talked it over with them. There was a whole back and forth, and we finally ended up recommending Kubernetes to them, which sounds great. Technically, it was the right choice to make, but somebody has to operate this Kubernetes, right? It's not on the cloud. Maybe you can get a managed service. This is where banks traditionally are. Some of them are much further along now. Your Society Generals and your JPMCs. JPMC is a bank, but your Goldman Sachs kind of people. They are far ahead of the game, but then they're driven internationally. But traditionally, banks would have IIS, ESBs, WebSphere, IBM servers. How many people have heard of all of these things? Not everything used to run in containers. Containers are fairly new, so the younger folk probably don't remember that. And then you'd have enterprise systems from IBM, Oracle, Microsoft. But the thing is, there usually won't be a lot of clear infrastructure, automation, or automation is too loose a term. Infrastructure orchestration, in terms of like your Nutanixes or they'll have VMware, but maybe not everything will be API driven. A lot of stuff will be manual because it's also sort of dictated by where the IT teams are. So there will not always be a clear centralized view. I cannot go to a bank and say, give me 50 compute instances and so many buckets of object storage. I can't go to the IT team and say that. You have to really work with them to get the kind of compute and storage that you want. So they would traditionally have long release cycles and everything will be heavily regulated. You can't do your GitOps or continuous deployments because releases are regulated. You can only release so many times per month in certain windows. And they'll have some cloud adoption. Typically what we are seeing is that a lot of people are adopting the Azure stack, for instance. But so then how do you get from here to here, right? So the question is, why did we pick Kubernetes, right? If you have all these operational challenges as well, right? You want to sort of go. So here's the thing. You cannot, if you're any enterprise, you're not going to digitally transform your IT the next day. You're not going to wake up today and the CIO says, tomorrow we will be completely elastic. That does not happen, right? So you have to kind of find inroads, which is what they wanted to do and what we were trying to help them with. So we picked Kubernetes because microservices or services, let's drop the micro, they run great on cloud. You have auto-scaling groups in your AWS. You have container services, etc. On-prem, what is the infrastructure abstraction that you might want to use? And there have been a few over the years. This is not a new problem. But we could not really go in and transform the entire IT operations. So what we had to do is to run our services, because remember, they came to us for functional application development. But we needed an infrastructure abstraction. So that's how we got into the infrastructure game to start with, because they did not have other people or internally who were yet at that sort of level of infrastructure automation. So we picked Kubernetes because it gives us consistent infra abstractions, right? It has APIs for provisioning your workloads. Everything is API driven now for storage, for scaling. It's all API driven, which is essentially what we wanted because that makes our sort of development experience much, much smoother. It gives you a framework for essentially building polyglot, resilient, elastic services, container orchestration, etc. And then in future, the big question was, do we do it on-prem, go on cloud? We can't go on cloud yet. So we're like, well, just run on Kubernetes, and then tomorrow if you make up your mind, or there's a strategy shift, just lift and shift the services to cloud. It'll just work, excuse me. Plus, there was great community support. That was the major driver, right? And there's high cost savings because it's more efficient. Instead of getting, 6 app servers and on huge boxes, we can share infrastructure now. So that's all well and good. You all already know this, right? The big question is, why didn't we use OpenShift? How many people are using OpenShift? A few of you, right? It's a great solution, right? Why didn't we just go with that? It's managed Kubernetes, essentially. And the reason is, again, we are not in a place to transform the IT operations of our customers, right? They have not really heard of Kubernetes. They had not, certainly 2 years back. We were selling it to them, which meant we had to start somewhere. And OpenShift, I mean, for those of you who are running it, it is an investment. It's a great investment if you plan to take it long term. But if you're unsure about this crappy, company that you haven't really heard of, that's us, who are proposing this newfangled thing, it's a big investment. It sounds like a risky investment. So we went back and forth. And then, obviously there are other platforms in the mix. Pivotal Cloud Foundry was still, it was kind of the platform of choice back then for the ecosystem in which we operate, which is sort of the Java ecosystem. You couldn't really run .NET on it. AKS Engine was out. You could run it on Azure Stack, obviously, but it's non-managed again. And then, you had IBM, Cloud Private, which kind of doesn't exist in its current state. Internally, there was Cloud Foundry again, and PKS had just come out. So we had a lot of back and forth. PKS, the reason we didn't, because they really pushed for it. I think for us as well, them going with a managed service would have made sense. IBM is pretty good at that. But PKS licensing, I think, then was per pod or something, which made no sense. You couldn't really scale that out. And OpenShift had its community version, which we could have gone with and migrated to OCP down the line. But, it's a community open source version in a financial institution. You want something that's at least heavily supported by the community. So, open source Kubernetes was that. We had enough sort of experience. This was not our first experience with Kubernetes. We had enough people, sort of managing OpenShift, managing cloud Kubernetes servers for a bunch, GKE, for a bunch of our customers. But this was essentially us having to manage the Kubernetes platform itself. So there's infra, which we don't get into and don't want to get into, and then there's the platform itself, which ideally, is this better? I mean, or is this too loud? Okay, I'll step back. So, where was I? Right. So community Kubernetes mates, like I said, we have application developers. We didn't really want to deal with the Kubernetes layer. We wanted to submit pods and deployments, but they're like, no, you have to run this platform as well. And then this is one division. You still have to go in and sell it to the other stakeholders within the bank because you cannot run forward of your IT teams, right? They're the ones giving you the infrastructure. So we kind of detailed out the components we had. And if you look at this, it's all open source, right? Once we could not go OCP, we essentially picked up we tried to get support for a couple of pieces for Docker, etc. But the people we talked to for the registry basically said, well, you can buy a Kubernetes managed cluster from us, and then you can run the registry on top of it. Like, I already have a cluster. I don't need another one. So this is, we needed a gateway, right? So something for Ingress. So that's where we ended up with Istio because, again, it's an enterprise, right? They don't just want north-south traffic. Everybody knows north-south, east-west, right? North-south is traffic coming into your cluster. East-west is traffic within sort of your data center or your cluster. They wanted governance on the east-west traffic as well. So a service mesh made sense. And we'd been talking to a few, we'd been talking to Google, etc. And they're like, Istio is now mature enough that you can really use it. Right, and then we had an SSO provider. So a lot of this, though, is kind of modeled on the OCP stack. It just seemed to make sense. The intent, I think, was always to go to OCP, but, make a start and really prove that this is a viable option as well. So you have, you can run a Redis cluster on it. You need object storage. You can run Minio. We are doing that now. You can run your services, have some vault integration for secrets, back it up with storage, which is a big story I'll get into. And then, have your logging, Kibanas, EFKs, Fluentd, Zipkin. How many people using Zipkin? Distributed tracing, yeah. Anybody using Jaeger, thinks Zipkin is crap and old, right? I thought so, but, we are from a Java background, Netflix OSS, Spring Cloud, etc. We were fairly comfortable with Zipkin, with running it. So then we had I hadn't really looked at Jaeger deeply enough yet to make a call saying, we'll go with this. But I want to get there now. I think, yeah. And then, Prometheus and Grafana, which ended up being a godsend, saved us a lot of stuff. And then a bunch of dashboards because you always want more observability. Right. To give you a sense of when we started, containerization wasn't really mainstream. I know because I heard those conversations, certainly in India, and a lot of big enterprises weren't really moving to containers yet. It's a big replatforming effort. This is what we were trying to do here, and this is the same is true for most organizations. This is about 2 years back, it's not that long back. OpenShift was, Red Hat wasn't IBM yet. So I said this statement last week. I said Red Hat was still Red Hat, and then a very nice gentleman from IBM came up and corrected me. He said, it's still Red Hat, which I know, it is its own individual entity, yeah. But OpenShift was on v3. CoreOS wasn't really integrated into OpenShift yet. It was its own entity. You could get CoreOS. You can't get CoreOS now. You have to go with Fedora CoreOS, or people are saying use Flatcar or whatever. Istio was just stabilized. I think version 1 had just come out. At least half of the current CNCF projects, I don't think they were even in incubation. And kubeadm wasn't yet the default install. How many people are using kubeadm to do all of their sort of production provisioning? Do you like it? Is it easy? Just say, yeah. It's nice. It just, there's still, to us, there was still enough manual steps needed there. This wasn't the default yet, so we had some. Today, if I went with it, we'd probably relook at it a little bit more closer. Today, just in the last 2 years, so much has changed, right? Everybody here understands what a container is. Everybody appreciates you need a container orchestrator. Kubernetes is the clear winner. It was still the clear winner back then, though. Yeah. And then you have operators now, the bold new world. You automate everything. There should be no manual intervention needed. You submit your API resource, and your CRD gets read, and it applies the cluster state. I'm willing to bet there are at least a few salespeople in here. No? Yeah, at the back, yeah. How easy is it to convince enterprises to adopt something completely new, and that to open source community-driven stuff? How easy is it? How did we convince them? That's the real reason we are here, honestly, I think so. So a lot of effort, we had to go in and do workshops. So convince the people we were working with, then convince the people they had to work with, then convince the infra teams, then talk to the security and compliance teams. And these guys, if something goes wrong, RBI will come and put them in jail, or so they say, with banks. So they have to be really convinced. And we had to take a bunch of exceptions nonetheless, because it's just the way Kubernetes works. You can only do so much. If you were on OpenShift, you have some backing with SE Linux or AppArmor or whatever, but community Kubernetes. And like I said, we were not really Linux experts. We built that expertise up. So, we had to convince them about each of the core components, and then we did a lot of estimation, capacity planning, etc. Because really what they wanted was something fairly ambitious, something that scaled a lot, which means you have to provision all this compute up front. They have to have purchase orders. They have to buy all this infra, or at least provision it on the VMs, but then VM servers are limited by the capacity. You have to buy new VM servers as well, VMware servers. Would be so nice to run on the cloud and just scale up whenever you felt like it. Which means we can't do node auto-scaling, for instance, cluster auto-scaling, pod auto-scaling is our limit. Okay. So the journey was, I don't know if you guys can see this well enough. So the confession, I have to make is I did this slide while I was sitting here right before this session. But, this started around July 2018. They came to us. We had a lot of discussions. I don't have a laser pointer, sorry. So, I'll just read it out. And then around September, we finally started pitching Kubernetes to them. We talked to a lot of people. Then we had to detail out each component, give comparison matrices, like I said, PKS, why not OpenShift or PKS or Azure or whatever? Why Kubernetes? And then we had to get architecture approvals, right? Governance approvals. And so I will say this, for the most part, everybody was really thrilled to have that transformation happening. It's just that It takes a little bit of due diligence, it takes some effort, somebody has to come in and be a little bit pushy, but everybody's thrilled with new technology. In any enterprise, their big problem is there's so much inertia, they really want to break that and really move fast, but it's always a challenge to do that. Once we were past that, we started kicking off. Now we had to give detailed, sort of hardware specifications, right? And that means everything, right? Down to which ports have to be opened where on which firewalls, because this is heavily regulated. So you have to prepare all of that upfront. Okay, how many people can predict where a pod is going to be scheduled across 8 nodes? Unless you put labels on it or whatever. Can you predict it? However, you have to give the IT team an architecture diagram saying, this server is where this application is going to run, this server is where this application is going to run, and then I have to go in and convince them, I have no idea where it's going to be scheduled, it might run on any of these 8. Yeah. But then we finally got everything we needed, and then we had your traditional IT scans. So they don't like that kubelet or Docker daemon has to run as root. They don't want anything to run as root, right? So a lot of discussion around that. But we finally went to production in April 2019. So not too bad. It got a little bit hairy at the end. And mind you, this is not just Kubernetes, right? We were actually doing application development for them. The reason I stress all of this is our platform engineering team was 3 guys. And our development team was about 10. So all of them are doing development, but these services need to be deployed across multiple environments. And they're waiting for the clusters to be set up. So yeah, a little bit of negotiation needed there. Okay, so what were the learnings? How am I looking for time? Yeah, I have 10 more minutes, right? Yeah, cool. So we learned that cloud and on-prem are very different beasts. Just because we got Kubernetes pods running on AWS and on GKE, and just because we got containers running on OpenShift does not mean we were in any way qualified to establish our own Kubernetes platform. Honestly, we didn't know what we were getting into, and that was the best thing possible, because we just went ahead and did it. Right? It's a hummingbird story. We did not know storage when we started. I can be fairly upfront about it, because the problem is, I want to just deal with, I'll give a persistent volume claim and I'll get a persistent volume. However, the underlying storage, there's no orchestration there. These guys are used to attaching disks manually or over the network. They had NFS, and they themselves didn't recommend our using it, because they're like, we've never quite certified it for production. So storage, I have no idea what IOPS was when I started. I had to learn all of these things, same with my team. Networking I knew a little bit, but then I had to kind of explain it a little bit to my application developers, Java application developers. But that was slightly easier. But again, I'm not an IT guy, My knowledge of networking is very different from what the operations team knows. So, yeah. And then again, we had to actually understand what exactly is a container, So I had to actually go back in and sort of, because I had to explain the stuff, right? What is a C group? What is a namespace? This is what a container is. This is how it runs. This is how Kubernetes schedules it. So we had to learn, and then you have to run this yourself. So what are the processes running on each worker node, on the master node? You have to actually detail this out very, very clearly. So we had to learn enough. And if a node restarts, what are the processes that should not just stay dead, that have to restart along with the node? The thing is, enterprise IT teams don't like it when you try to circumvent, we weren't trying to circumvent them, but try to run ahead of them, right? They have their own standards and practices. They're meant to safeguard security. They're meant to safeguard their jobs as well, Whatever we were doing felt risky to them. So our goals, obviously, were to install and operate Kubernetes using only community tools, right? Manually on VMs from scratch, RHEL VMs, no CoreOS there. And then obviously get the DevOps into place, CI/CD pipelines, figure out governance strategies so that I don't have a big DevOps team. This was my team, by the way. When I say I actually mean I actually leading the initiative. which means we have to bring in as much automation and governance as is possible and sort of redevelop from scratch whatever OpenShift gives you out of the box. And then you sort of govern Istio in a flexible enough manner to govern East-West. How many people are using service meshes, Istio, Linkerd? Yeah. A lot more hands in Bangalore last week. I actually had a few Linkerd contributors. Okay. I will take 2 more minutes, is that fine? And then I'll close, right? So the learnings were run all processes as Docker containers, no open internet, so you actually have to get all the images into the enterprise Docker registry. We used KubeSpray to set up on RHEL VMs. Anybody use KubeSpray? No? So it's essentially an opinionated wrapper around kubeadm. Gives you a lot more tooling, but it's slightly slow. Not a big problem for us, but it uses Ansible playbooks. It sets up the Calico overlay networks, etc. And then we set up some admission control policies. And Helm charts were a big, our friend, because all of those components I showed were installed through Helm charts. In case the chart didn't exist, we went in and wrote our own. And this is sort of the size. It's not great for cloud. Intuit, for instance, last week, we're running 1,200 nodes on AWS. We have about 50 across various clusters. There's an experimental cluster to test out upgrades. And then there's a non-prod, prod, and DR. And then some of the dashboards we did. I really like ViewScope. I'm not sure that it just looks so pretty. I'm not sure I've ever figured out how to read the information, which just looks so pretty. But Prometheus is a godsend. It can monitor Istio performance. It can actually monitor our SSO server and, sort of your Java memory utilization, everything. You'll be tied each of the services to essentially get Prometheus to scrape their data. So very, very useful to track memory issues. And then, custom auto-scaling. We have something called backends for frontends, which is essentially Zool gateways from the Spring Cloud stack. They're not memory intensive, they're IO intensive. So we had to plug in Istio to that to sort of scale per connection. And then, timeouts, retries, rate limiting, all of that stuff. Should I close? Or do I have 5 more minutes? Or okay, great. Well, I was hoping for somebody from, okay. Operational problem areas. Like I said, storage orchestration was a pain. Ultimately, we ended up with NFS. We tried out Gluster. Anybody's tried out Gluster? Everybody seems to hate it nowadays. I've talked to a few people. Again, we are not storage experts, so sort of operationalizing it proved complicated and was still backed by NFS. Ultimately, we ended up with NFS. It's working out fine. But now I'm kind of looking at CAS and Rook, basically doing the storage orchestration from Kubernetes itself. So looks more promising now. Helm. Helm with Tiller was super painful. Thankfully, Helm 3 is out now, but it kept blowing up initially until we kind of figured out how to massage it to run nicely. You can't really do a lot of dynamic configuration with it. It keeps blowing up, but yeah. And then, our Prince Istio. So Istio configuration gave us the most problems, especially with TLS. We had a lot of problems with sort of connection pooling at the gateway level. And then with the certificates, we can't use Cert Manager because this is all closed down environment. You have to have a purchase order for certificates as well. So stuff kind of works, sometimes Istio has a lot of configuration for a lot of special use cases, and sometimes some of them just don't behave and traffic stops coming to your cluster. So a lot of that. So what we learned was, don't run Kubernetes adoption in front of sort of traditional IT teams. You have to work hand in hand. And so we learned from a bunch of, they'd restart the etcd node. etcd would crash, the entire cluster would go down. Not on production, thankfully, but sort of on the lower cluster. So we had to kind of work with them to set up a good sort of governance practice and tell them, okay, this is when you do this stuff and you let us know. And these are the sort of automatic restarts we'll set up. Had to figure out how to sort of work well with the registry, which sometimes if it goes down and your image pull policy is always, the service goes down, right? And hasn't that happened with anybody? No? Okay, it's even 9, yeah. This is sort of, okay, so 3 nines, no comment, I guess, but I'm hopeful we'll get to 3 nines. I think you'll agree it's kind of a challenge, but we want to kind of, the expected peak load is 5,000 transactions per second. We have enough infra, so the challenge is more about if things go wrong, then we have to recover really, really fast. Fine. Should I close? Because nobody's coming to push me off the stage. Not sure what's... Okay, you guys want me to continue? Do let me know if I have to run off, if the next speaker is waiting for me. Yeah. Okay, you're already here. All right, so I'll step off. I kind of wanted to show this up. So we have a Gradle build, and that essentially handles the entire build lifecycle. Jenkins just calls a Gradle build. So because we can't afford a lot of overhead, Gradle bootstraps every service, and that has all of the operational stuff inbuilt already. So essentially, you just write the code, business logic code, and sort of your environment-specific configuration, and it seems to work well enough, typically. Like I said, there's only like 3 or 4 people. So, you have you build it, you run it mentality, you have to then help out with production, which is fine. Startups do that all the time, right? And then security is sort of Kubebench, Docker bench, CIS benchmarks, all of that stuff, traditional scans, image hardening. We had to actually go in and do all of this manually, right? No OpenShift. And then we do sort of quarterlies, do these activities quarterly. So I guess in conclusion, the reason for this talk is, yes, it is possible to, sort of adopt Kubernetes across your enterprise, your traditional enterprise, even running on-prem with the community version. That's a lot of great support, every time I think we should write our own operator, somebody's already written it for us, and we just do due diligence and then get the approvals to pull it in. Fine. I will run off, but can I get a selfie with you all? Thank you.